Now our device is ready to write our first program. So let's start our first program to run a counter on port 1. We'll save the project. Now we'll run the Microvision Keil. We'll go to the project and we'll select new Microvision project. Here in documents, we'll go for electroeducators, and here in course contents, we'll create a new folder. And we'll give the name, that is sample programs, and here we'll create another folder, new, that is counter program. And we'll assign the file name, that is counter project. Okay, save. Now we'll select the device, and here we will write, that is AT89C51, and here we have AT89C51 microcontroller. Select OK. First we'll go for target 1. Right click, option for target 1, and here we'll select the crystal oscillator, that is 12 megahertz, 12.0, and we'll select the output, and here we'll check out the box, that is create hex file. OK. Here we can see startup, that is A51. We will delete this page, delete, OK, and we'll go and we'll say add new item to group, source group 1, OK, and we'll select ASM and we'll write the name, that is counter program, and we'll select the folder. Here we can see the folder is there, counter program, OK, add, and here we have a new page, counter program. We'll just close this page. Now we can write our first program. We'll start writing our program by semicolon like this, and here we'll press equal sign. The semicolon means that the compiler will consider this line as comment and it will not compile this line. So here we will use this semicolon to write our comments in our program. And here we'll write, that is my first counter program, So here we have added comments to our program, and we have learned that how to add comments in our program. Now we'll give some directions to our compiler, that is from where to start writing our program. So here we will write the directives or the program directives. And here we will write program directives. And here we will write, that is org originate address 00h. It means that we are directing our compiler to start writing our program from the location, that is the address 00h of the ROM location. So here we have given a directive to the compiler that start writing our program from 00H location. And here we will write, that is jump. Here I will insert a subroutine name, that is ini underscore r. In this case, the compiler will write the jump instruction on 00H location of the microcontroller ROM. We will see that what is the jump instruction. Jump instruction is for the microcontroller, and ORG, that is originate, is the instruction for the compiler. Here I have written the jump initialization routine, and the addresses from 1 to 29, we will not use these addresses because they are the addresses for the interrupt vectors of this microcontroller. So here we will write here again we will write originate 30H, and here we will start our initialization routine, that is INIR. So here we will write initialization routine and here we will write initialization routine using colon. Whatever the name we have given to our subroutine will be followed by colon. So the compiler will consider this name as a label of our program, and here we'll write our first initialization instruction, and we will write move port 1 comma hash 00H. So here we have initialized the port to 00H. This instruction will move the number, that is 00H or 0, to port 1, and now we'll write our main program. Main program, and here we'll write a routine, that is main routine. And now we'll write our main program, and here we'll write move port 1 comma R0. R0 is the internal register of the microcontroller, and we'll learn that what is this register, that is R0. We have 8 registers, that is from R0 to R7 is a 1 register bank, and we have 4 register banks in our microcontroller. We will learn that what are register banks. So here we have moved the value of R0 to port 1, and now we will initialize the value of R0 as well. So here we will go and we will enter move R0 comma hash 00H. By placing a hash before a number means that we want to move a direct number to the port or any register, and here we have moved the value of R0 to port 1, and now we'll use another instruction, that is increment the value of R0. Okay. And here we will call a delay routine, and we'll write, that is call DLY R. It means that we would like to call a delay routine to see the value on port 1, and now we'll write jump to main, and from this line our program will jump to the main routine and will continuously move the value of R0 to port 1 and then increment the value of R0 and will call a delay and will again go back to the main program. Now we'll write the delay routine like this. Here we'll write delay routine. And here we will write our delay routine, that is DLY R colon. Now here we will write decrement jump not 0, and here we have used the instruction that decrement a register, and if this register is not 0 then jump to a location. So here we will write which register, that is R1, comma, where to go, DLY underscore R. And here on this line the microcontroller will find an instruction that is decrement jump not 0 R1 go to delay routine. So it will decrement the R1 and it will check. If it is not 0 then it will go to delay routine, and then it will again come and decrement the register. If this register will be 0 then it will go to the next line, and here we will write that is decrement jump not 0 R2, which is another internal register of the microcontroller, comma, DLY underscore R. So it will decrement the R2 and will check. If this register is not 0, it will again go to the delay routine, and we will see the result of this delay routine in our program, and then we will discuss in detail that what we have written in our program. And here we will write a return instruction, that is RET is the return instruction, and here we will end our program like this. And here we will write end of program. And here we will write end. Here we have completed our first program to run a counter on our microcontroller. Now we'll compile our program and we'll check if there is any error in our program, and we'll go for the compile. Here we can check 0 error, 0 warning, build time lapsed 2 seconds. Now we'll check the hex file of our program, and here in the folder that is sample programs which we have selected for our programs, we'll go to the sample programs, and here we'll go for the objects, and here we can check the counter project.hex file is there. We'll load this hex file to the microcontroller and we'll observe the result of our project. And now we'll select the microcontroller, right click, edit properties. We will select the program file and we'll go for the course contents. Here in sample programs, go for the counter program, and in objects, here we have the hex file. We have downloaded the hex file to the microcontroller, and the frequency of oscillation is 12 megahertz, or the clock frequency is 12 megahertz. Okay. Now we'll run the program and we'll observe the result of our program. Here we can find our first program is running, and we can observe a counter that is a binary counter on port 1, It means that we have successfully developed our assembly program and we have downloaded the hex file to the microcontroller. In our next lecture, we will learn that what are the different commands which we have used in our assembly language program and why we have used the registers. This program was just to show you that how to write assembly language program and how to download your hex file to the microcontroller. And in next lecture, we will learn what are the different instructions which we have used in our program and what are the basics of writing this program for your microcontroller. Thanks for watching the assembly language programming course. We hope that you find this course very helpful to learn assembly language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.